Hey Algebra 2, welcome back to part 2 of section 9.6. We left off here at example 4. We're going to talk about this rate problem. Now the speed of the current in the Puget Sound is 5 miles per hour. A barge travels 26 miles with the current and returns in 10 and 2/3 hours. What is the speed of the barge in still water? So the first thing we want to do is just consider the relationship that we know that rate or speed and time and distance have. We know that rate times time is going to give us the distance. And so that's the first thing. The second thing we need to think about is that there's two things happening. This barge travels in one direction and then comes back. And here's what we know. We know on one trip, the barge travels at a rate of r, some rate, its regular speed, plus 5. Why plus 5? Because of the current pushing it forward. So r plus 5 times the time, whatever this time is, let's call it t sub 1, is going to give me 26 miles. So the barge travels 26 miles with the current and then returns against the current. So that's r minus 5 times t2, and that 2 is equal to what? 26, because both directions it was 26. So the information that we're given in this problem is the total time. So what I'm going to do is take both of these equations and solve them for t. So t sub 1 would be 26 divided by r plus 5. You see that, divide both sides by r plus 5. And then t sub 2 would be 26 divided, not 2x, I don't know what I'm talking about. Okay, would be 26 divided by r minus 5. And so what we need to do is to realize that t sub 1 plus t sub 2 has to equal our total time of 10 and 2/3 of an hour. So we're going to use this information to answer the question about rate. Watch this. So we have 26 over r plus 5 plus 26 over r minus 5 is equal to 10 and 2/3. And since we're in fraction mode, I'm going to just make this thing a fraction. 10 and 2/3 would be 32 over 3. We know how to solve these. This is just a rational equation. We want a common denominator. So since each of these are mutually exclusive, like they don't have anything in common, our common denominator will be the product of all three. So this is our common denominator. I'll spread it out. And let's go ahead and come up with the equation that we need. This is going to be 26 times 3 times r minus 5. Remember, including everything that was not originally in the denominator. Now that is in the denominator, we include that in the numerator. 26 times r, well, let me add my 3 in there too. 26 times 3 times r plus 5. And here we have 32 times the r plus 5, r minus 5, that I'm going to write easily as r squared minus 25, because we know what happens when we multiply those. So now we have our equation. I'm going to kind of ignore this denominator like we've been doing, and then I'm going to distribute through. So this is 26 times 3, which is like 78. Let's try another color there, which is going to be 78. And that's 78 times all of this business here, r minus 5. And then over here we've got 78 times r plus 5. And then 32 r squared minus 32 times 25 is going to be, I can do it, guys. It's going to be 80, 800, 80, 800, 800. So now that we have this, after distributing, we're going to cancel, oh, this is 390. We're going to cancel these guys out, and we're going to simplify. All right, had to make that a little bit smaller. So you see we get our 156r is equal to this thing here. And you know what, guys? It looks like we've got a quadratic. R squared definitely says that. We know what we do with quadratics. We move everything over to one side, set it equal to 0. We get this. Now we're going to see if we can factor something out to simplify this. Maybe we can factor. And the only thing I was able to take out is a 4. So how do we solve this? I'm not seeing a good way to factor this, guys. I think we have to pull out the quadratic formula. And so the quadratic formula, if you remember, is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all of that over 2a. We have it in the right form. Let's go ahead and apply. We get r is equal to the opposite of b, and in this case, the opposite of b will be a positive 39, plus or minus the square root of b squared, so that's negative 39 squared, or just 39 squared, because we're squaring it, we'll get a positive answer, minus 4 times a, which is 8, times c, which is negative 200, all of that over 2a, so 2 times 8. When we simplify, so we get r is equal to 39 plus or minus 89 over 16, which implies that r is going to be equal to 8 or negative 3.125. And since you can't have a negative rate, that just doesn't make logical sense. It makes sense that the rate of the barge, didn't you forget what we were doing? Me too. The rate of the barge in still water was 8 miles per hour. 8 miles per hour. Let me write that down. And I said I could do that in a couple of minutes in that last video, but I couldn't have. It took a long time. All right, let's go ahead and do this final one. So here we have to solve a rational inequality. So when you're dealing with an inequality, oftentimes it's really convenient to compare your number or your rational expression to 0. So what I'm going to do is I'm going to alter this a little bit. I'm going to write 1 over 4a plus 5 over 8a. Watch this, minus 1/2 is greater than, well, if I subtracted 1/2 from both sides, I've got 0 here. And this is going to be convenient because, and you'll see why. So what I'm going to do is try to solve this in a way where I'm going to simplify this and have it all as one common denominator. So the common denominator, you might be able to see it, is 8a. All of the other denominators fit nicely into 8a. And so that's what I'm going to deal with here. And so what I multiplied this denominator with is 2, so I multiply the numerator. Here there's no change, so there's no change in the numerator. And here we multiply by 4a, so we're going to multiply the numerator by 4a. And we're still comparing this to 0. So when I simplify, I get this. 7 minus 4a is greater, 7 minus 4a over 8a is greater than 0. So in this situation with the inequalities, we do not just ignore the denominator. We need to consider what makes the denominator 0. And what would make this denominator 0 is 0. So now I'm actually going to consider what's happening on all of the number line by considering the special places that are referenced in this particular rational expression. So one of the special places is where the denominator is 0, and that is at 0. So I'm going to mark that off as a place of interest. So I know that my equation cannot equal 0, so I'm going to put an open circle right there. This expression can't equal 0, rather. The second thing I'm concerned about is where this thing does equal 0. Remember, I want it to be greater than 0. So I need to know where it's equal to 0, and that's going to give me another mark of importance. So let's think about that. 7 minus 4a is equal to 0. So when the numerator of a fraction is equal to 0, that's when the fraction equals 0. So 7 minus 4a equals 0 implies that 7 equals 4a, specifically that a is equal to 7 over 4. You guys see that? And so that's what, 1 3/4. So here's 2 out here. 1 3/4 is another place that we're interested in. Remember, we want it to be greater than 0, not equal to 0. So at 1 3/4, we know that that is not a possible answer. Now, the interesting thing here is when we pick these critical values, what we do is we split up the number line into areas where we can either have, I'm going to say, compliance or defiance of the expectation here where this expression is greater than 0. So what I'm going to do is choose a number here, check to see if the number in this section is greater than 0. If it is here, then it is everywhere along the number line in this section. Then I'm going to try the center section and then the next section. You guys get me, right? All right, so what number could I try here? Let's say like a -1. If I put -1 here, the numerator would end up being positive. Do you guys see that? 7 minus 4 times a -1, that's going to be a positive 4. That's going to be a positive answer. But if I put that same -1 in the denominator, that's negative. A positive divided by a negative is going to be negative. So the answer in this whole section, less than 0, is negative. So I'm going to put a little minus sign there to remind me. Now I'm going to try a number here between 0 and 1 and 3/4. Let's try 1. It's an easy number. It's pretty simple and easy to substitute in there. So if I put a positive 1 in here, I get a positive answer at the top. Do you guys see that? 7 minus 4 times 1 is going to give me a 3, which is positive. And if I put a positive 1 here, I get a positive answer. Notice, positive over positive is just positive. So that tells me everything in this section is going to give me a positive answer for this expression. Finally, I'm going to check something above 1 and 3/4, which is 2 is good enough for me. When I plug a 2 in here, I get a number that's a little bit bigger than 7, therefore this is negative. And I put a 2 here, I get a positive. So this section is going to be negative. Now let's go back to the question. We wanted to find something that's going to satisfy this. And then we translated it to this. So we're comparing to 0, which makes life a little bit easier. So now I can see I'm looking for something that's going to make this expression greater than 0 being positive. So the section I'm concerned about is here. So my answer is all A values such that they are between 0 and 1 and 3/4. Sometimes we write this in what we call as a parenthetical notation. You can write the answer as from 0 to 1 and 3/4. And by using these curved brackets, it means that you're not including those two numbers. If I wanted to include them, I'd use I call it a hard bracket or a rectangular bracket if I were including those, but I'm not. So this is our answer, or this is our answer. A such that it's between 0 and 1 and 3/4. Gosh, that took longer than I expected, but I'm glad we got to talk about it, and I hope it makes sense. Guys, let me know if you have any questions. I look forward to talking to you soon. Have a good one.